For these three problems, now we're going to simplify these other three problems using the exponent rules. So number 4, always work with your numbers first. I like to draw a square around it so that you notice that just the numbers, leave the variables for later. So here we have negative 16 over 12. Find a common factor between negative 16 and 12. And the common factor is 4. You can divide 16 into 4 and 12 into 4. And when you do that, 16 divided by 4 is negative 4 because it's negative 16. And 12 divided by 4 is 3. So I'm left with, in the numerator, I have a negative 4, and in the denominator, I have a 3. Now let's work with the variables. Two things you could do here, and we're going to do both. Anytime I see a negative exponent, I take the variable and I switch their position so that it becomes positive. So m to the negative 2 power, I can bring it downstairs and make the exponent positive. In the denominator, I have m to the negative 5th power. That means I need to change the position and bring it to the numerator so that it becomes a positive exponent. There it is. Once I do that, now I can use the quotient of powers rule, which says that you can subtract the exponents if you're dividing and the bases are equal. So in the numerator, you have negative 4. In the denominator, you have 3. And if I subtract 5 and 2, I keep the base, so I keep m, and 5 minus 2, 3. And there's your answer. Another way of attacking this problem, after you've simplified the numbers, so now I have negative exponents, you can use the quotient rule and just subtract exponents. And when you do that, you keep the base and you subtract negative 2 minus negative 5. So you'll have negative 2 minus negative 5. Negative 2 minus negative 5, remember, this becomes plus. So what you really have is negative 4 over 3. When you have different signs, you subtract, and that gives you 3. You get the exact same answer as you did using the other method. Which method should you use? The one you like the most, the one you're most comfortable with, as long as you get the same answer, okay? Let's do number 6. For number 6, we have a multiplication. These two big parentheses, there's no operation between the parentheses. You don't see a plus sign, you don't see a minus sign. That means that we're multiplying. So we're multiplying everything here times everything over here. Again, we take care of our numbers first. So negative 6 times negative 10, that gives you positive 60. Then we take care of our variables. T to the 3rd power times t to the 5th power. I'm multiplying. That means I can keep my base and add the exponents. 3 plus 5, 8. P to the 8th power times p, I'm multiplying, so I keep the base and I add the exponents. What's 8 plus 1? P to the 9th power. And you're done. For number 6, we're going to do this one. There's really not a lot to do. We're just going to rewrite it and make it legal. The first thing I notice is that I have a 20. There's nothing to multiply 20 by or divide by or simplify, so just keep your 20. The next thing I notice is I have m to the 0 power. That just equals 1, so it's 20 times 1. Then I have p to the 8th power, nothing to combine that with because there's no other p's here. And then I have t to the negative 2 power. Notice this variable has a negative exponent. So I need to always write my expressions with positive exponents. So how do I make this exponent become positive? Well, since it's in the numerator, if you bring it down to the denominator, that's how we make the exponent positive. And now we just rewrite it. 20 times 1, 20. 20 times p to the 8th power is 20p to the 8th power over t squared. And there you have it. I hope this helps. I'll see you tomorrow in class.